Hey guys, welcome to today's lesson video. You should go ahead and get out your interactive notebook and something to write with. You're going to take literally 2 slides of notes, that's it. And then you are going to practice the equation that you learned today. So it's really important that you have really neat handwriting because you're going to be turning in the notes as well as the practice. And all of this is going to be worth 15 points. So make sure you take really good notes. You're going to take a picture at the end and then you're going to upload it. After you finish today's lesson video, then you are going to work on some physics practice, calculating speed. So let's go ahead and get into it. So we have started learning about motion and what motion is. Motion is essentially what physics is. Physics studies all different types of motion, and today we're going to focus on one type of motion, and that is speed. We're going to focus on what speed is and how to calculate it. But first, it's meme time. Because, it's not Mrs. Roebuck's science class unless we have a funny meme, right? They're not even funny. They're just straight up cringy. For every meme, there is an equal and opposite meme. Ha 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 ha. That's Isaac Newton. That's talking about one of his force laws. For every action, there's an equal and opposite reaction. Now, this one's really funny. Newton's third law of emotion instead of motion. For every male action, there is a female overreaction. Oh, clicked out. And then we have, this says inertia. Sorry, that thing is in the way. Inertia is when something is moving and then all of a sudden it breaks. It's still, that item still thinks it's moving. So in this case, we have a truck that had this giant cement block in it. And then when the truck braked, guess what didn't break? The cement block. So the cement block kept moving and it ran into the front of the truck. So sad. Okay, so let's talk about what speed is. Speed is the distance of an object that travels per unit of time. So we're looking at two main things here with speed. Okay, we have distance and time. These two things combined, distance and time, is what makes up speed. So it's how far an object goes in a certain amount of time. So let's look at what that would be if we were to calculate it. So let's look at distance. Distance is a change in position. So something goes from here to there. It moves. It moves in distance. It changes position. And the most frequent units that we will see for distance is meters or kilometers. Now, there are definitely other units. You could definitely add centimeters, inches, miles. There are a ton of different units for distance, but it's important to know all of the distance units. Then we also have time. That's a big part of speed. Remember, distance and time. Time is the rate in which an object moves. So some different units would be seconds, hours, minutes. That's about it. Although you do have months and years, but I don't think anything can travel for that long without running out of gas. It would have to stop almost, eventually. So seconds, minutes, and hours, those are the units of time. And then we have speed, which is the distance an object travels per unit of time. So speed takes distance and time and puts it together into one word called speed. So a unit equals meters per slash mark second. So we can take meters and replace it with kilometers. We can take meters and replace it with inches because it's all depending on the equation that is given to you. So if you're given an equation and it gives you the distance in meters, you know that your speed is going to be in meters, okay? So whatever your distance is, whatever unit it gives you for distance, that's going to be incorporated in your speed. Now you'll notice that speed has two different units combined. This is one whole unit, okay? That's because speed is legitimately the combination of distance and time. So its unit is going to combine a distance unit and a time unit to make one whole speed unit. So meters is from distance, second is from time. So these will definitely change very often, but it's all dependent on what unit is given to you in the equation. If it doesn't give you inches, don't just put down inches, okay? If it gives you hours and you put down second, that doesn't make sense because you want to put down the unit that it actually gives you. You're probably been wondering, what the heck is this triangle over here? Like, what is that? This is called a DST triangle, okay? And I'm actually going to show you what that is in the next part of the video. So to recap, speed is the distance an object travels per unit of time. So speed combines distance and time together. And here are the different units. We have a unit for distance, which is meters or kilometers. It could also include centimeters and inches. We also have time, which is represented by seconds, minutes, or hours. It's the rate at which an object moves. And then when we combine distance and time, we call that speed. So it's the distance an object travels per unit of time. You'll probably often think of speed as miles per hour. That is what we use to calculate the speed of a car. How many miles did you go in 1 hour? That is what speed is. Okay, now that we have learned about what speed is and the general equation, we are going to learn how to calculate for speed, distance, and time. Because speed, distance, and time are all related. So I want to draw your attention to this chart. It's a triangle. This is called a DST triangle. And this triangle actually has the formula for speed within it. So I'm going to teach you how to read this triangle. That way you can learn how to use this triangle to help you calculate for speed, distance, or time. So let's say you're given an equation and you're looking for speed. Okay, we know that the normal equation for speed is d equals d over t. Okay, whenever we're trying to find speed, distance is always over time. But what if we're looking for time? What if we're looking for distance? What do those equations look like? Now, you could memorize these three, or you could just memorize this one triangle, and then this one triangle actually has all three of these equations in it. So let's take a look. Let's say an equation is asking for you to find the distance. So you don't know the distance, you're trying to solve for it, but the equation gives you speed and time. What you're going to do is you're going to cover up the d, and it gives you the two letters left, speed and time. Now you'll notice that speed and time are next to each other. Because they're next to each other, you're going to be multiplying speed and time. So whenever you're looking for distance, you're going to cover up distance, you're going to cover up whatever you're looking for, and whatever letters are left, if they're next to each other like this, you're going to multiply. Let's do another example. Let's say a equation gives you, it's asking for you to find the speed of an object. It gives you distance and it gives you time, but you have to solve for speed. So you're going to cover up whatever you're trying to solve for. And what's left is your equation. So we're left with d and t. Now in this case, d and t are not next to each other. D is actually on top of t. So you are going to be dividing, okay? So your distance is going to go on top of the equation, and your t is going to go on the bottom, just like our normal equation right here. Let's do another example. Let's say an equation gives you distance and speed, but it asks you to find the time of the object. Well, remember, you cover up whatever you're looking for. So you're going to cover up time, and what you're left with is distance and speed, which means in your equation, you're going to put distance on the top and speed on the bottom, because these are the two values that the equation has given you. And you're going to, again, divide with distance over speed. So this is a really cool tool that will help you if you forget which equation depending on what you're looking for. So with that in mind, we're going to move on to some practice problems. So I drew my little DST triangle up here. I really suggest drawing a big version like this to help you memorize it and just to have it big and somewhere for you to see when you are practicing. So we're going to do the first question. It says, how far does a car travel in 0.75 hours if it is moving at a speed of 88 kilometers per hour? Okay, so the first thing when we're doing equations and we're solving for speed is we want to break it down. The first thing we want to figure out is, what are we solving for? Are we looking for distance? Are we looking for speed? Or are we looking for time? So when we reread the question, it says, how far? When you think of the word far, you don't think of speed and you don't think of distance, or time, you think of distance. How far? How far is something? That refers to distance. And so it's asking us, how far does a car travel? Well, we don't know that because that's what it's asking for. So we are looking for D. D is our unknown variable. Let's look at the next piece. How far does a car travel in 0.75 hours? So there is a piece. Now, based on the unit of hours, we know that 0.75 is representing time because of the unit of hours. With these speed equations, units are going to be super helpful in helping you understand what pieces are you missing and what do you need or what do you already have. So we have time. So our time is 0.75, and you always, always, always want to go ahead and carry that unit over. Next, it says 0.75 hours if it is moving at a speed of 88 kilometers per hour. So it tells us it's moving at a speed of 88 kilometers per hour. So we know that S equals 88 kilometers per hour. So now we have all of our things needed to solve for our variable. So we're looking for D. So going back to our triangle, whatever we're looking for, we're going to cover up. So in this case, we're looking for D, so we're going to cover up D, which means that our equation is going to be speed times time. So in this case, we are going to multiply speed times time. So our speed is 88 kilometers per hour. Okay, that's our speed, times time. And our time is 0.75 hours. Okay? So when you plug that into the calculator, you should be showing your work, but you are always welcome to plug into the calculator when you're solving for that final value. And when you plug it into the calculator, you are going to get 66. Now, 66 what? Well, we got to figure out a unit. You can't just put a number. That doesn't work. You have to have a unit because this is not just math equations. This is science. These are real life scenarios, and we need to know what 66 represents. So let's look again at what we're solving for. We're solving for distance, okay? So we know our distance is 66, but 66 what? Meters, miles, what is it? Well, when we look at our units over here with all of our variables and all of our information, these are the only possible units that could be 66 because those are the only units in the entire equation. So could it be 66 hours? No, because we're solving for distance. That doesn't make sense. Hours is not a unit of distance. Well, what about kilometers? Yeah, kilometers is definitely a measure of distance. Let's look at the last one. Hours again. Hours is not a unit for distance. So kilometers is the only unit within our problem that could represent distance. So we know that our distance is 66 kilometers. And we're going to go ahead and circle that final answer. Okay, so you should have gotten 66 kilometers. Let's go ahead and move on to the second question. Okay, our second question is, an ant travels 75 centimeters in 5 seconds. What was the ant's speed? So let's dissect what we're looking for. It says, what was the ant's speed? So that's what we're looking for. We're looking for speed. So S is our unknown variable. So that means we have D and T. We just got to figure out what that is. So let's reread it. An ant travels 75 centimeters. We know that centimeters is a unit for distance. So that is our D, 75 centimeters. In 5 seconds. Seconds is a measure of time, so we know that our T for time is 5 seconds. Okay? So we are looking for speed, we have distance, and we have time. Let's go back to our triangle. Now we're looking for speed. So when we go to our triangle, we're going to cover up whatever we're looking for. And what we're left with is distance over time. And because one is over the other, that means we are going to divide. So we're going to put D on top and T on the bottom. And again, you can go ahead and draw that triangle right here. It's super easy. D, S, T. Okay? Just as an easy reminder. So because we're looking for S, we're going to put D on top. Our D is 75 centimeters. And on the bottom is time, which is 5 seconds. And when you plug that into your calculator, 75 divided by 5 is 15. But we're missing a unit. 15 what? Well, speed is a combination of distance and time. So in this example, the unit for distance is centimeters, and the unit for time is seconds. And because speed is a combination of both distance and time, we're actually going to be combining the units as well. So it's going to be distance first, so it's centimeters per second. Okay? Speed is the only variable where we're going to have two different units. Time, we're only going to have one. Distance, we're only going to have one. But speed, we're going to have two different units. And that is my final answer. So I am going to circle it. So you should have gotten 15 centimeters per second. Also, this is a really fast ant. Like, an ant travels 15 centimeters per second. Like, that ant is pretty cool. Okay, last one. And then you are going to practice on your own. Okay, so it says Trevor walks at a speed of 4 kilometers per hour. How long will it take him to walk 20 kilometers? So let's figure out what we're looking for. It says how long. Long represents time. So that is our variable. T is our variable. We're looking for time. Now let's review the question. Trevor walks at a speed of 4 kilometers per hour. So our speed, or our S, is 4 kilometers per hour. How long will it take? So that's our T. We don't know how long it'll take. That's what we're going to solve for. How long will it take for him to walk 20 kilometers? So there's our distance. So D equals 20 kilometers. Now let's go to our DST triangle. We're looking for T. So when we go to our DST triangle, we're going to cover up T, and what we're left with is D over S. So we're going to put our distance on top and our speed on the bottom. So our distance is 20 kilometers. And then we are going to put our speed on the bottom, and our speed is 4 kilometers per hour. So what is our time? 20 divided by 4 is 5. But 5 what? We need a unit. So in this example, it's actually pretty cool. Another way to figure out the unit, yes, you can go through here and figure it out, but when you have a division equation, if you have two of the same unit, you can actually cross it out. So I have kilometers up here and kilometers down here. So I can actually cross that out, and I am left with hours. And that is my unit, 5 hours, because I'm solving for time. And because that's my final answer, I am going to circle it. So again, make sure you have this DST triangle written somewhere nice and big so you can see it. And it will help you remind you of all the different equations that you can use, and it will definitely help you on your practice that you're going to do next. Thanks for watching.